Good morning. We are VRIL group composed of Ana, Santiago, and Alejandro. Today we are presenting the conductivity of different solutions using distilled water and magnesium chloride.
To begin with, electricity. Electricity is something that we use every day. We use it to light up our furniture. We use it to light up our appliances. We use it to light up our gadgets. But to understand electricity, we must have some context as to the makeup or structure of electricity. Electricity is really an electric charge of subatomic particles called protons and the negative charges, which are electrons. We mostly use electrons to power up our appliances or whatever we use every day. Electric current is really an electric charge that moves. Current is the movement of electric charge, and so electricity is really the movement of electrical charge of primarily electrons. And this is what we're going to be seeing today: the conductivity of certain chemicals like magnesium chloride or sodium chloride. Further, sodium chloride in the liquid or aqueous state or molten state are good conductors of electricity. They allow the flow of electricity because in the liquid state the particles Na positive and Cl negative ions can move freely, thereby allowing the transfer of electricity. In addition, sodium chloride in a solid state are not good conductors, and this is because the molecules are in a fixed or parked position, and consequently this friction resists the movement of electrons. And the type of salt or the effectiveness of this magnesium chloride or sodium chloride, or the concentration of it, also affects the conductivity of this material, and it is determined by the density of the charge, of the number of ions, and the size of the ions also. So sodium chloride is a better conductor because it has more ions to carry the movement of electrons. Furthermore, as you will see in this lab experiment, that we have two electrodes here, and you will see that they form a closed circuit, and you need a closed circuit because you need current needs a complete path through which they flow. And also you see that they are called electrodes. They're called electrodes. Electrodes is basically a conductor through which electricity can flow. At this moment I'm going to present Alex to continue to their presentation.
Hi, my name is Alejandro, and I'm going to perform the experiment using distilled water, magnesium chloride, and a 75-watt light bulb. First of all, you have to remember to wear your goggles, your gloves, and your apron. Now, the first thing that you're supposed to remember is, well, first thing to know is, how does light travel through water? And if it does, how? Okay, so first, remember to take off the plate for safety, and put the light bulb in first, and then connect it into the outlet. And as you see here, the light bulb isn't lighting up, so therefore there is no electrolytes in the water, and that is the primary way that electricity flows through water, by the use of electrolytes. So, safety again, disconnect and then remove the light bulb, and then for another safety precaution, top it, move it over to the side. Now we will perform the experiment using magnesium chloride. And as before, remove the disc off the solution, and then put the 75-watt light bulb into it first, and then plug it into the outlet. As you see here, the light bulb lit up. Therefore, the magnesium chloride has electrolytes within the solution. So, and as you see, if you could see closer, there are bubbles forming around the electrode. So that is one way to see that the electrons are flowing from the electricity outlet and into the solution and into the other electrode, creating the electricity. Now to remove from the outlet and remove the light bulb. Remember to close it and safely place everything back where it was. Thank you. I am Alejandro.
This concludes our presentation, and thank you for your attention.